The inverse square law. Let's consider a point source of something that goes out equally in all directions. This could be electromagnetic radiation, such as light. It could be an electric field. If we consider a sphere at a radius r from the source, and then another sphere at a radius 2r from the source, and a sphere at a radius 3r from the source, whatever is coming out from this source must pass through this sphere, and this sphere, and this sphere. But the area of a sphere is given by 4 pi r squared. So as r doubles, the area of the sphere will go up by 2 squared, or 4 times. As r trebles, the area of the sphere will go up 9 times. If we assume for simplicity that the property being radiated out is light, and then consider in this diagram the light travelling out in just one small direction from the point source, a radius r out, we could have a square of area A, and all the light in this direction passes through this square. A distance 2r out from there, the light will have spread and would pass through an area 4a. So for example, if we just had this square of area A, we would only get a quarter of the light passing through it. We've doubled our distance from the source, and we're getting a quarter of the energy through an area A. Going 3r from the source, we now have an area 9a. And so if we again consider one square of area A, it will now have 1/9 of the light intensity that this square had. So as we double the distance from a point source, the property, which we'll assume to be light, is spread over 4 times the area, and so is of 1/4 the intensity. Treble the distance, we would have 9 times the area, and so 1/9 the intensity, and so on. We can write that intensity is inversely proportional to distance squared, or in symbols with I for intensity and R for distance. We can also write that intensity I would be equal to the power P divided by 4 pi r squared, as 4 pi r squared is the area of a sphere of radius r that all the power emitted by the point source must pass through. This is known as the inverse square law and applies to any property which is radiated out equally in all directions from a point source.